data presentation. So data can be categorized in two main categories. Firstly, we know we have what we call qualitative data, and we have what we call quantitative data. So we need to differentiate what qualitative data is. We need to differentiate what quantitative data is. So what is qualitative data and what is quantitative data? According to your own understanding, what is qualitative data and what is quantitative data? So these ones may differ in terms of nature, measurement, in terms of collection methods. So I would say the following in terms of nature. So quantitative data can be defined as data that is numeric in nature. It has numeric characteristics that can be measured, and these involve objective measurable data points like height, weight, temperature, and other numerical counts, whereas qualitative data describes properties and qualities that cannot be measured in numerical terms like the color, the texture, the feelings, the opinions. So that is qualitative data. Now, in terms of measurement, the difference between the two would be as follows. Qualitative data can be measured on a nominal or ordinal scale. So nominal represents categories that have no inherent order, like place of birth, either born in one place or the other, or gender, you're male or female. So you can have ordinal shades, which represent categories with specific order of rank. For instance, satisfaction. To what extent are you satisfied? Very satisfied, little satisfied. There's quantitative data can be measured in an interval or ratio. We could also have what we call discrete and continuous data. So it has interval or ratio scale. So in terms of measurement, we can define quantitative and qualitative data. It can also be defined in terms of what? In terms of data collection. So in terms of data collection, we can say quantitative data is collected through interviews, open-ended. That is for qualitative. We can use interviews, open-ended surveys, observations, where we're going to describe behaviors. Whereas quantitative, we use surveys, experiments, questionnaires, which should be structured or standardized. In terms of data analysis, qualitative, we use thematic analysis or content analysis or narrative analysis, which involves identifying patterns, themes, whereas quantitative, we use statistical tools like SPSS, Excel, to give information statistics and graphical representations. So that is the difference between the two types of data. Now, these data can be represented by pictograms like the pie chart, a histogram, the bar chart, the box whisker plot, the stem and leaf diagram, the cumulative frequency graphs, accumulate the relative frequency polygon. Okay. And many other types of pictograms. So A is a pie chart, B, histogram, C, bar chart, D, the box and whisker plot, E, semi-leaf diagram, F, cumulative frequency, and G, this is a relative frequency polygon. So how do we now compute the pie charts? So pie charts, A, B, C. So you could have 2, 4, 2, 4, 6, for instance. These are the values. So to find the pie chart, we add the figures. The total here we're getting is what? 12. So 2 over 12 times 360. To find in degrees. 4 over 12 times 360 degrees. Then we have 6 over 12 times 360 degrees. So these ones represent, here we're going to get 180 degrees. Okay. Then the 4 will give us 120 degrees. That is 4 times 360 divided by 12. Then we have 2 times 360 divided by 12. We have 60 degrees. So we know that a straight line is 180. So this represents part C. Then 120, 90 is somewhere here. 120 is somewhere there. So this will be represented by B. And finally our A is there. So you can make your key. A may be led by colors. So this is how we draw a pie chart. Right. We can also use the same data to calculate or to draw a histogram. So out of 12, instead of the pie now, we're doing a histogram. Histogram is attached. So maybe we have apple, banana, and carrot. So we have A, B, and C. 2, 4, 6. So A is at what? 2. B is at what? 4. And C is at what? 6. So you see the blocks are attached. So it should have titles here, either fruit and what? Number of likes. I give it a title here, types or preferences. The same can be done with a what? A bar chart. Except that the difference will simply be very small. So we have A, B, and C. 2, 4, 6. Our A is at 2, our B is at 4, and our C is at 6. So these ones are detached. So that's how a bar chart looks like. All right. So we can go to a frequency polygon. So we have X values here, maybe 2, 4, 6. Okay. We're looking at fruits. A, B, C. The frequency is 2, 4, 6. The likes, community frequency here, 2, add to 4, 6, add to 12. So meaning our N here is what? Our N here is 12. So relative frequency, we divide by the total here. Relative cumulative frequency, we divide by the sum figure. So this will be 2 over 12. This will be 4 over 12. This will be 6 over 12. So what is 2 over 12? 0.167. 4 over 12, it's 0.33. 0.6 over 12, 0.5. Whereas the relative frequency, we use these figures here. 2 over 12, 6 over 12, 12 over 12. So this is 0.167. This is 0.5. This is 1.0. Then you can graph them. Okay. So 0.1, 0.2, 0.3, 0.4, 0.5. We have A, B, and C. So A, 0.167, so somewhere there. 0.5, somewhere there. Or 0.33, 0.33 is somewhere there. 0.5 is somewhere there. So it's a polygon, not structured. We can also use the cumulative frequency A, B. Cumulative is always going up to 100%. Okay. 0.2, 0.4, 0.6, 0.8, and 1.0. So A is at 0.16, so we put it there. B is 0.5, put it there, and C is at 1.0, put it there. So this one here is called a cumulative frequency graph. We could as well look at the data in terms of what? 01, 02, 11, 10, 13, 11, 12, 21, 29, 22, 22, 20, 24, 32, 33, 36, 41, 50, 62, 50. So we'll come up with a stem and leaf diagram to depict the data that we have here. So we have numbers that start with zeros, we call them the stems. 0, the last number is the sixth one, 2, 3, 4, 5. So on the zeros, we have 0, 1. We put a 1 there. There's already 0, 0, 1. We have 0, 2, the 2 there. So on the zeros, we are done. On the ones, we have 10. Smallest is 10, 1, 0. And then 11, 11, so 1, 1. Then 10, 11, 11. Then we have what? 12, 13, so 12, which is 1, 2, and 13, 1, 3. And on the 20s, the smallest is what? 2, 0. 2, 0. Then we have 21. Then we have 22. Another 22. Then we have 24. And 29. On the threes, we have 32. 33. 36. On the fours, we have 41. The fives are 50. 50, and the sixes, we have what? 62. So this is how we draw the stem and leaf diagram. So these are the leaves. You put a key there. Key, you can say 1 and 2 means what? 12. That is how we draw the stem and leaf diagram. So this is on the pictograms. We end here for today.